My name is Bill Turville. I'm the lead artist on the Waldo Tree Project. Friends of Waldo Park saw that this tree stump was left after a big storm. And they said, we need to do something about it. So they got design suggestions from the neighborhood, basically. Everybody, anybody. And they came up with the sketch for this multi-trunk tree. Then they needed someone to make it into a project. They got a sense of what my capabilities were, so they said, well, can you be the lead artist for making this tree into something? And at first they wanted to carve all those animals and stuff out of the tree itself. And then as it developed, it turned out that actually making the individual animals from other things instead of carving them out of the tree did two things. One, it allowed the work to be done off-site, and we weren't worried about safety of kids in the park and weather, and so we decided to make it kind of mixed media. And the ladybugs we determined would be best screwed into the trunk. What are we going to make them out of? I know Karen Christians is a metal worker. We call up Karen Christians. She says, oh yeah, that'd be great. We can do this as a demonstration project for my friend who's got a 3D printer and he wants to do this test pour of his work. And so Jim came in with Karen, and they both produced, engineered, put together the whole aluminum ladybug process. So all I had to do was to make some models. So I made some clay models, which everybody agreed was a good start. And then Jim took those clay models and translated that to a 3D printing program.
My name is Jim Brett, and I've been working in three-dimensional printing for about 20 years now, and I got involved in this project with Bill Turville to make some patterns for the public art sculpture. The parts that he wanted me to make were some castings of ladybugs, and I decided to make 3D printed patterns because he needed 3 different sizes of patterns, and we were able to digitally magnify the same pattern to 3 different sizes to make casting patterns, and then we built these patterns on a 3-dimensional printer in my lab. The furnace design was something that I developed over the course of a few years while I was in high school. Now, the furnace was a pretty simple affair. It was just assembled out of a stack of fire brick. Have to use fire brick. Construction brick will crack and crumble under the heat. But fire brick, we laid out a floor of of bricks lying on their side against the. It was just tarmac on the driveway. So we put a layer of fire brick on top and then stacked up a cylindrical stack, a little tower around the crucible, basically it's held together by their own weight, and a few pieces of ceramic fiber in the cracks to keep the gases inside the chamber. The fuel source is a bottle of propane, just like what you use on a gas grill, and the burner is essentially a collection of pieces of gas pipe where the gas coming out of the propane tank entrains some air as it passes through the burner and mixes in the pipe, and then makes a pretty healthy flame inside the chamber of the furnace. The patterns that we made were used in a green sand process. Now, what green sand is, it's regular silica sand, very much like beach sand, with some clay mixed in and a little bit of starch adhesive, and some water. And the water basically binds the sand together. It's a non-toxic mixture, and it's recyclable, and you just simply add more water to it when it dries out and reuse it. To make the molds for casting these parts, we use a metal flask that is basically a box with 4 sides on it, but open top and bottom. And there are 2 parts that are actually called cope and drag. And these boxes fit around the pattern, which is mounted to a wooden board. So the pattern has holes on it that align with pins on the flasks, so that when everything is clamped together, these patterns are held rigidly in the correct location. Then these flasks, once they're clamped together, you load the green sand into the spaces around where the pattern is, and ram it down tightly against the pattern. Now these patterns, these ladybug patterns, are essentially hemispherical, and you have them facing down on the lower half of the mold, so that when the metal flows in, its weight pulls it into the cavity. And in the upper side of the mold, what we did was we took some stainless steel screws, large diameter screws, and inserted them into the sand, so that when the metal cast in, it would cast around the screw head and embed the screw into the casting. And when that's done, you have essentially two large loaves of compacted sand inside the flasks. And then you open up the mold very carefully and pull the pattern out, and then everywhere where there was relief standing off of the board that the patterns were mounted on, it leaves a cavity in the sand. So when the mold is complete, you assemble the pieces, you clamp it together rather tightly, because you don't want the mold pieces floating apart from each other when you pour the metal in. And even aluminum, which is a light metal, is dense enough to cause the sand to float up. And so what you get when you're pouring the metal in, and this happens pretty frequently in the foundry, is you get just little jets of metal squirting out the side, and it can actually be quite dangerous if it's a large mold that you're pouring from a big height. So it's especially with little kids around, you want to be very careful that everything's clamped together tightly. Aluminum officially melts at around 650 degrees Celsius, which is just a temperature just below the point where it begins glowing red hot. So it actually gives you a pretty good visual cue of when the metal's the right temperature, because you just heat it up just to the point where you can barely perceive it starting to glow. And then you know you have about 100 degrees of heat above its melting point, and that's the right point where to pour it. So you pour the metal into the mold, and it cools, it freezes off in maybe about 2 or 3 minutes, really not very long at all, but you do have to let it sit quietly. So what I tend to do is just arrange it so that I have another job to work on that keeps me occupied, because there's a cooling phase, particularly with aluminum, where it's very sensitive to mechanical shock. So you can't really rush the solidification process. So really I'd pour the molds, and then I would just distract myself and everybody else with some other task for about 5 or 10 minutes. And that was generally reconditioning the sand from the previous heat. So I'd have enough sand to make 2 molds, and the sand left over from the casting before would have cooled off sufficiently that then I can break up the chunks and add some water and mush it all together and begin to make it sort of like a smooth modeling material again. And so once that was done, generally that would take about 10 minutes or so. As soon as that was done, then I'd know the castings were cool enough and go back and shape them out of the molds that they were in. The cycle that we ran from making the molds, smelting the metal, pouring the metal in the molds, letting it cool, and then shaking the castings out, and then reconditioning the sand, it was about an hour per cycle. So making the molds was about 20 minutes, melting the metal was about 20 minutes. The casting takes like 5 minutes, and the rest is all cooling time. Once it came up to temperature, see, the bricks retain a lot of heat. The very first heat took about an hour and a half. But then after that, the bricks, most of the heat was just heating up the bricks, and once the bricks were hot, then you keep the cycle time going quickly, and they don't have a chance to cool off in between cycles. So we were doing, basically the metal was melting faster than I could make the mold. All of them. Cavity for the bottom half of the mold first.
I think we're going to use the smaller sizes. This one might be a great thing to sell, or a promotional item.
Paperweight.
One more. I think it's our last.
One. Okay. Last one?
Last one.
Last one.
These are 5 of the cast aluminum bugs. They're still attached to their sprues and gates, and what I'm going to do is just cut them off with a hacksaw. This particular ladybug is a very good cast, needing cleaning up. So I've marked it with a piece of tape to let us know that. What I'm going to do next is probably just file off this edge.
Did you say nerd? Okay, now I've got it. There we go. Nice.
Don't do in the dark. Dark, stay good.
Okay. See how quickly that does that?
Yeah, wow.
See, it's really good.
So that's how the aluminum ladybugs came to be, and we also sold some of those to make money for the tree project. And it turned out that it seemed right to carve the hawks out of wood because they would be the ends of the tree trunks. Then we thought we would carve the bunny and the squirrel into the tree trunk, but because I knew Kevin Duffy as a local stone sculptor, we thought, geez, if we had a stone bunny, that would be even better. So Kevin agreed to carve the bunny, and he and I carved a niche for it in the tree and inserted his beautifully carved stone bunny into the tree as one of the first animals. I found a local wood carver named Pete Howard, and he carved the first hawk, which he called Waldo. I am using my wood carving background to carve the second hawk, my mixed media background to make the third hawk out of wood from the tree plus other pieces of material. I'm working and finished actually the woodpecker, which is made out of recycled aluminum and other parts, including a license plate. And the only remaining animal is the squirrel, which I'm going to try to again make out of a mixture of the tree parts and probably metal, which is what I usually use metal and wood in a lot of my work. So I'll be making the squirrel with pieces of wood likely as the body and or metal parts.